Stop scrolling. Have you noticed the number 1 shows up way more than 9-inch real-life data? That's not a glitch. It's a mind-blowing pattern called Benford's law, and it can even catch fraud. Here's the hook. If you grab a random set of real-world numbers like populations, stock prices, river lengths, social media followers, the first digit is most likely 1, and it gets rarer as you go up to 9. Not evenly split. 1 is the superstar. 9 is the underdog. So what exactly is Benford's law? It predicts that in many natural datasets, about 30% of numbers start with 1, around 17% start with 2, and it keeps dropping until only about 5% start with 9. That's the opposite of what most people expect. You'd think first digits would be evenly spread, but the real world doesn't play fair. Why does this happen? Think growth. Lots of things in life grow multiplicatively, not additively. Bank balances with compound interest, viral views on a video, bacteria populations, even city sizes. When values scale across many magnitudes, say from 1 to 1 million, lower first digits naturally get more airtime. Numbers spend more time passing through the 1 second than the 9 second on their way up, so the 1 second dominate. Here's a quick mental picture. Imagine a price growing by 10% each step. It takes many steps to go from 1 to 2, but fewer to go from 8 to 9. That slow climb through the 1 second gives them more chances to appear as the first digit. Where does it show up? Everywhere you wouldn't expect. Electricity bills, earthquake magnitudes, street addresses in a city, scientific constants, even the areas of rivers. NASA datasets, economic reports, and academic studies have all observed it. When data covers several orders of magnitude and isn't capped or artificially limited, Benford's law often emerges. Now, the wild part. Investigators use it to spot fraud. If someone fakes numbers, say in expense reports or tax returns, they often sprinkle digits evenly because that feels random. But real data is Benford biased. Auditors compare the first-digit distribution to Benford's law. If 1 second are suspiciously scarce and 7 second or 8 second are too common, red flag. It's not proof on its own, but it's a powerful clue. The IRS, forensic accountants, and researchers have used it for years. The American Statistical Association and forensic accounting literature discuss this as a standard screening tool. But there are limits. Benford's law doesn't apply well to data with built-in minimums or maximums, like human ages, test scores out of 100, or prices that cluster just under 10. It also struggles with data that's tightly bunched around one scale. Think of a grocery aisle where lots of items are $2.99. Those first digits won't be Benford-friendly. Here's a fun test you can try. Take the populations of countries or the follower counts of the top few thousand accounts on a social platform, grab the first digits, and tally them. You'll probably see more 1 second than 2 second, and way fewer 9 second. Spooky? Maybe. Useful? Definitely. In short, Benford's law is a hidden fingerprint of how the world grows and scales, turning messy data into a predictable pattern and giving us a clever tool to detect when something looks fake. Want more mind-bending math and science in plain English? Comment with a dataset you want us to Benford test next, and subscribe for more mind-blowing facts.